Hello. Hey, thanks for welcoming me. This screen here is what we look at all day, so it calms my nerves to know that everything is green. This is the Kobo infrastructure monitoring system that's watching the live traffic. But I'll turn that off now. Okay, so today I'm going to say a few things about Kobo, about deploying data centers, and how to do it quickly. So this talk is probably going to be a lot better if you actually interrupt me and ask questions. If you have anything that particularly strikes your imagination, or if there's something that you would like to have more detail on, please interrupt me and say, hey. That will be a lot better for everybody and more interesting. So please feel free. I'm not going to do a separate QA session, so you just interrupt me if you... Yes? Question? Oh, okay. I thought that was quick. Okay, so there is a lot of stuff that I would like to talk about. So I'm going to go through the kind of the simple things fairly quickly so that I have more time to spend on the more interesting parts. Which means that if I fly by, you have to go like, hey, that was actually more interesting. Okay, so a little bit about myself. First, I'm from Amsterdam. I live in Canada now. I've been doing internet engineering for quite a while. And I did infrastructure design and management for some of the bigger sites. You may recognize some of them. I work at Kobo as the VP of Operations. And I assume that everybody knows what Kobo is, but just in case, we sell books on the internet. We have a catalog of 3 million books at the moment that we sell. We have 6 million readers in 200 countries. And we've been doing it for 3 years. So if you think about that, building a platform that sells books in 200 countries and having these millions of books and users, 3 years is actually not that much. That's 36 months, right? Is it? Yes, it is. Good. So I'm going to talk about a few things. One of them is speed, how important it is to automate stuff. The 7 days claim that is in the title of this presentation, and then maybe if you do have questions, if we have time, we'll go through that. Well, first of all, speed. Speed is actually one of our main motivational slogans, principles. We try to do things as quickly as we can. Why? Because our main competitor is Amazon, and Amazon's Kindle team is 10 times our size. But at the same time, we need to push out. So the only thing that we have is that we are more nimble and quicker because we have fewer meetings and we can get stuff done faster. That is our competitive advantage, if you will. And now that we have the backing of Rakuten, obviously the risk has been reduced. But definitely before the acquisition, that was one of the most important things. We were kind of fighting for our lives because otherwise we're going to be obsolete. So doing work at Kobo speed, as they say at Kobo, is much like trying to replace the engine of the train while it is moving, while somebody else is painting the outside of the train and a third person is laying tracks in front of the train. So it's actually very challenging in that environment. Sooner than they can. So our roadmap changes a lot. The technologies that we use change a lot, and as such, there's a lot of change in our environments. So to save time, we try to automate as much as we can. Actually, there's only a few very specific things that we don't automate. And to give you a little bit of an overview of I don't know if you can see everything. This is a rough sketch of how our infrastructure looks. So we have a bunch of front-end servers. Some of them run Windows, others run Linux. We do a lot of open source. We have a lot of open source installations like Solar and MogalFS and Memcache, Membase. And all these, every box that you see basically has different development teams. We have 14 development teams now that constantly modify the code and make changes to schemas in the database and add new features, change things on the front end, on the back end. It is very tricky to make changes safely and at speed. And at the same time, our customers, we have devices in the field, the Kobo e-readers and the ARC devices, and then constantly newer versions of the apps on iOS and Android that are coming out. And we need to make sure that everything works together pretty seamlessly. So that if you are going to check all those things manually, you're going to lose. It's not going to work. So we focus our automation efforts in 3 areas, and 2 of them I'm going to cover today, and they are provisioning, code deployments, and routine tasks. I'm not going to talk about routine tasks because we don't have time, and I'm waiting for a lot of interesting questions. So first, provisioning. Provisioning means that we are able to scale up relatively quickly. Most of the year we have a kind of a steady growth, but 2 days or 3 days in the year it is really crazy, and those days are Christmas. Why? Because we sell millions of tablets and millions of these e-reading devices, and then especially in North America, within a span of a couple of hours, millions of people sit under the Christmas tree at the same time, and then they all open their device. They're present and find a Kobo e-reader, and they turn it on, connect to the Wi-Fi, and they all connect to our backend systems at the same time, and that's crazy spike. So we make a lot of our revenue is made in relatively few hours. So we want to make sure that we can scale up quickly if we need to. So this is how provisioning worked in 2010, 2011, and 2012. In 2010, turnaround time to add 1 server to our infrastructure was 5 business days, because we were at Rackspace and we were renting our infrastructure. It was all outsourced, and you needed to basically place an order with them, and the turnaround time was actually fairly long. It took 1 engineer 6 hours to provision such a server. The turnaround time for servers went from 5 business days to 2 hours. And it took 1 engineer 1 hour to provision something. And you can see that it actually scales up, because that same engineer can set up 50 servers in just 4 hours. And the trick of that is, of course, that we added cloud capacity to our infrastructure. More about that later. Now in 2012, we actually cut down a little bit more. We made some things, some optimizations. And the turnaround time is now 30 to 60 minutes for a server, and it scales up really nicely. Like, we've had situations where somebody said, "Oh, I need a new environment to stress test this," and we spin up 25 a complete environment with 25 machines, and it takes 30 minutes, 35 minutes. So it's really nice. If you saw the talk earlier about Jenkins, by the way, we use Jenkins everywhere in our backend. It's awesome. If you are not using it, you're doing it wrong. But go use Jenkins. Jenkins is absolutely great, and go do it. They did not pay me, no. They did. Oh, are you paying me? Oh, crap. Okay. So how does this provisioning work? I'm going to go through this pretty quickly, because it is actually quite basic, right? So somebody sits behind the desk and configures, for the physical hardware at least, the MAC addresses and puts them in a database. We have a custom database called CMDB, and there's an imaging server. You boot them over the network, and then they get there. It runs a little tool that takes inventory of the MAC addresses and then sends them back over to the server. I think we have IPMI cards in our servers, and through the IPMI interface, somebody built a very clever script that discovers these things. But what we still need to do afterwards is, for example, say where this server is located. based on the serial number. So we can read the serial number, but then you still have your Excel spreadsheet with the serial numbers and where you rack mounted them. Good question, by the way, because it is a little bit painful, but it's at least now it's script assisted, so it's not automatic. But it's certainly less, and you only have to do it once, right? And this problem of provisioning your own hardware actually became much smaller since we use cloud instances and VMware as well. But there are still some things that you actually want to run on bare metal. It's just fewer cases. So where you can, once you give them a name and assign roles to these servers, basically you pixie boot them. So these servers come up, and in their BIOS they don't boot from their local hard disk, but they boot from a network server that gives them an image. And actually Linmin manages that. So in Linmin you can say, oh, on the next reboot, this server should reformat its hard disk. Or on the next reboot, don't do anything. And the default is, of course, after we provision it, on the next reboot, don't do anything, because that would be potentially not good. Linmin is a kind of a hack-together project that it's a commercial product, but it's based on Clonezilla, if you know it. And one of the nice things about it is it actually has an API. So you can curl, you can do HTTP requests into Linmin and do provisioning with it. It is a little painful to get it working, but it works. Once it's running, it actually works fine. But so the PixieBoot server talks directly to CMDB, to our database. So once we have it in MySQL, no, we usually that's the first thing we set up, right? So you come in the new data center, you set up your PixieBoot server. There's a deployment server, and they package that nicely as well. Yeah, basically. I think some of the guys actually brought a whole VMware infrastructure with them on a laptop, because it's not that that hard on the hardware. So, and then after this baking process, all these boxes come up, they pull an image, and then they format their own hard disks. And after that, we basically have two classes of machines. We have Windows machines and Linux machines. Yes? It gets a bit slower. So there is multicast support in there. We're not using it. We probably should. But we figured we will burn that bridge when we get there. If it gets really slow, we will use multicast. We have not gotten to that point. Yes? I wouldn't know. We haven't done it. So. Yes. Yeah. 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 So it's one of our principles to only solve problems when we have them, unless there are problems that you can see coming that you cannot resolve quickly. So yes, you should expand the capacity of your RAID set if you need to order hardware, and it takes 3 weeks to get the hardware. But this is, premature optimization is the. It is fun, but we're too busy. But we're too busy. Good questions, though. Keep them coming. So the next thing that we do is code deployments. Oh, wait a minute. Let me go back for a sec. The two boxes on the left. So once those servers come up with their base image, the Unix server is connected to Puppet Master. Who here knows Puppet? Who uses it? Okay, if you're not using Puppet and you have Unix servers, you should. That's good. Or use Chef. And our Windows. Okay, this is I don't have time in this presentation to go over that. To be honest, it's actually pretty close. Puppet was actually, I think, mature a little bit earlier. So we used, and back when I was a kid, we didn't have anything else. So our Windows servers, there is no Puppet for Windows. We're going to start using it next year. but we don't have it yet. So we have our own homegrown replacement for that to really configure servers. It's called Crutch. It's based on Cygwin. So we run Cygwin on all our Windows servers, and then they have OpenSSH running, and you just SSH in with a key, and we execute PowerShell over SSH, and it's awesome. Through Jenkins, by the way. You made me very sad now. So when I started working at Kobo, the person that was hiring me was asking me these questions like, have you ever used, you know, how's your Active Directory? I was like, not very good. What do you know about .NET? Nothing. And he asked me those questions, and I was like, well, you know, have you looked at my resume? I've done 20 years of Unix stuff. Maybe I'm not the guy for you. You know, if you want all this Windows stuff, maybe I'm not the guy. And but then he said, well, you know, we're not married to you to Windows. If you can make it run on something else, that's fine with us. It's like, okay. So when I was hired 2 years ago, we were at 95% Windows shop. Now we're at 40 and dropping. So, but you know, to be honest, some of it isn't half bad. Some of it isn't actually bad. I wouldn't go so far to say that it's good, but it's not bad. And with Cygwin, it's actually very manageable. Right? Well, people say Microsoft system, whatever thing. There's these kind of all-in-one tools that they provide, and then it has all these bells and whistles, but it only works with this version of Windows and not with that one. And the feeling that I always have is that it really ties you into that ecosystem. OpenSSH is our common language across all our machines, basically. And with Puppet, it will go a bit further. Oh, shoot. Okay, let's continue. So the next thing is code deployment. So we do code deployments fairly frequently. This is a little bit of an overview of that. So when I started in 2010, there were 2 dev teams, and they were working really hard all the time. We still do, actually. But it would mean that a code release involved everybody. The whole company was busy with this code release. And we did one every 3-4 weeks, and people were sleeping under their desks, and it was fairly normal. During a release, that a release took 3 or 4 days, and people were sleeping at the office. That was completely normal then. The approval process was, well, QA says, I think we should deploy it, and then Galperin, the VP of R&D, would say, yeah, okay, let's do it, or he would ask a lot of questions because he's a very smart guy. And then at the end of it, an email would go out saying, well, yeah, we deployed. So in 2011, we actually went from 2 development teams to 5 development teams. And in 2010, it was basically a devices team that built the e-reader stuff and the backend stuff, the web and backend stuff. In 2011, we actually had iOS applications and Android applications and those kind of things, and they all had their own release schedule. So we did releases every 2 weeks. And then the team that was doing a release, they would be involved with it, and they would take 2 or 3 operations engineers, which was basically the whole team then, almost. The approval process was a little bit better. We used Jira. We have been using Jira since the beginning. But now we actually put releases into a Jira ticket, and we made that people had to comment on the ticket to say, like, okay, I sign off on this release. So we went from every 3 to 4 weeks to every 2 weeks. It was better. And then in 2012, it actually got a little bit crazy. We hired a ton of people. We now have 12 development teams, and we deploy our code, push our code once or twice per week, and on very good or bad days, once or twice a day. So you can imagine that, you know, going from it takes the whole company to do this to it is something that we basically need to be able to do on the fly now takes a lot of infrastructure work to get there. Furthermore, we went to almost 200 developers, I think, but the operations team is actually very small at Kobo. We have a total of, I think, 16 people now, but we go for quality, not quantity. It means that basically for every 10 developers, there's one ops engineer, and that means that everybody who we hire, they have to automate their work all the time, right? So nobody does anything manual on the team. You basically program most of the time. Communication improved. We have a release calendar. I should turn that off. We have a release calendar, an automatic email goes out, and we have graph overlays. If I have time, I can show that to you. I could probably do about a 45-minute just demo of all the tools that we built and that we're using. Is anyone interested in that? Maybe after this. Can you raise your hand if you would be interested in that, to just see the kind of stuff that... Okay, that's good enough. So we'll figure something out after. So I want to talk a bit about version chooser. Yes? Oh, that depends what the commit does. Is it a hot fix? Is it a small fix of something? Is it an average? I would say 3 days maybe. 3 days, 4 days maybe. Instantaneously. That's what I'm going to talk about now. So, yeah. So we have something that we call version chooser that we built in house. So this is actually a project that the operations team did. So this didn't come from the developers, but we did give specifications for the hooks that we needed to be made in the code base. So basically, version chooser allows us to run multiple versions of the code in production, live, on our production systems. So this is a bit the life cycle. These are statuses of a version. A version comes into our system under the name ready to deploy. That means that we did all kinds of packaging and some configuration on the package. That means that you can choose to deploy it. Once it's deployed, it's not live yet. It just copies in the background. It just copies the code to all our servers using Jenkins. By the way, hey. What? Nobody's going to believe you do it, so you better pay up. So the next thing after the code is there is actually we can activate it. And activating means that you, under Unix, you would need to make changes to your Apache configuration, maybe. And then under Windows, we need to configure IIS. To have a separate application pool or add another application to the pool. So once it's active, it doesn't actually take traffic yet. That's only when you default it, and you can go from active to default, and from default back to active, and from active to removed. So that looks a bit like this. So there's always exactly one default version that's taking the live traffic on the site. And there's 0 or more active versions. So this is how that works. Say that I have a version, and I have version 10 running on my site, right? That's the default version. It accepts all new sessions that are coming in. I deploy a new version and I activate it. That's version 11. That has a different feature set, or changes. Things may have changed. So what's interesting to know here, I will go back a little bit and wait. There, that's the one I wanted to show. So this is basically a distributed application, right? So every of these boxes in these different tiers has different versions of the software. So the problem is, once I start rolling out changes, what can happen is that I have a live session on my of a user. For example, he's in the middle of doing a buying a book, and I'm rolling out new code, and now the backend code has changed, and the next API call that is being made, badness can happen, right? Or our tax calculations may have changed, or whatever. So I want to make sure that those sessions stay intact, and that's one of the main reasons why we use version chooser. There must be an easier way to do this, but. I hope you're not getting dizzy. Okay, so This is the active version. So in the active version, we can actually test it. If you send a special header, you go to the live site, but you go with a special with a special header, and that's exactly what our QA team does. They basically test the code in production. That's not the first test that they do. That's kind of the final smoke test to make sure that nothing stupid happened or nothing unexpected happened. Right? When we default a version, all the new traffic goes to version 11, but all the existing sessions stay on version 10. So we keep all those sessions intact, and that is a pretty handy thing. So how that works? You guys, who knows mod rewrite? Raise your hand. Good. So mod rewrite is an Apache module to use regular expressions to rewrite incoming URLs for your web server. They ported that to IIS. So it's called ISAPI rewrite, and it basically works exactly the same as mod rewrite. So what we do is we set cookies. The code sets cookies on new versions, on new sessions, and these values of these cookies we associate with a certain path in the application. So it is not slash read this book.html, but it is /version v11 / read this book.html. And based on this cookie, my mod rewrite configuration will internally translate that URL so you end up at the right version. Does that make sense? Or not if you understand this? Okay, good. So we basically built an engine that can dynamically generate these rewrite rules, and it keeps track of which version is active, which one is default, and make sure that it's always consistent. So this is what the tool looks on the front end. Some of the guys went a bit crazy with the JavaScripting. We used the Twitter released a framework to do front-end development called Bootstrap. And they bootstrapped our whole suite, so it looks pretty nice now. But what you can see here is that the hash that you see here is basically the cookie value. And if you put this in your version cookie, you will get this version of the code. And if you don't have that cookie, you go to the default version. It was built by an engineer, and the current status is active. And I can also see that there is actually a version that is defaulted right now. So once you're updating, the update process to go from active to default or from deployed to active looks like this. There's a button that says make default. And it comes with a nice warning. If you click on this button, it will actually change the rewrite rules so that any new session that does not have that cookie value goes into the new code. So it ramps up slowly, which is good. Then there's a confirmation screen actually after you say, okay, go make default, because we want to make some of these changes. Actually, it shows you some of the servers that is going to deploy the changes on. This comes from CMDB, by the way. This the same database that we use for deploying. That the data is showing up here. And what you can see here is, this is the last chance to change your mind. Be very, yes?
How long is the average user session?
What?
How long is the average user session from code? How long does an existing session run?
We basically wait till they close their browser. Repeat it. So yeah, the question was, how do I know that? How do I know that? Or what is the average length of a session? I think most of them terminate in a few hours, and then there's always the long tail. Basically, if it's long tail, we don't really care because their session expires anyway, and then they weren't in the middle of buying a book, basically. Yeah, within 2 hours usually, everybody is over, right? But it actually shows you that some of the approvals are missing. So there's approvals associated with this release that haven't been done yet. So there's a link here, and then you can click on the link, and then you basically come to this screen. After authenticating, it shows you this. Like, okay, this is the change that you want to make. This is usually not the engineer that's doing the deployment, but either one of the managers or one of the QAs. And it shows you the type of change and the type of sign-off that is required. And there's two buttons that you can push. One for yes, this is okay, and one for it is not okay. And then there is a red button that appears at the bottom of that screen, which is basically your final go to actually make those changes in deployment in the production environment. So we try to make it kind of scary, that people don't take it too lightly to actually make these changes, even though we do them sometimes more than once a day. This is Jenkins. So in the backend, so you have this snazzy web interface with the Ajax stuff, and it all looks nice. But in the backend, it's all SSH, rsync, and Jenkins. So it just basically runs shell script in the backend to actually do all this stuff. And if you go one layer deeper, this is the rewrite file that is being generated. Right? So you see here, it checks active version, and it actually, our rules engine inserts comments so that even if you have a human has to parse the rules file, you understand what it is for. So here it says like, oh, that's this deployment. This is actually the Jira ticket number. Oh, wait a minute, this is not the terminal. This is not a terminal. It actually puts the Jira ticket number in and the time of when it was deployed. So here, if you have a version cookie, then rewrite it to this version. If not, then go to the default version. Is basically what this says. Okay. So the benefits of version chooser. QA can test things or do the last final check in production if they're unsure without panic. Before it was always we push something live and then the clock is ticking because QA says, oh, maybe something is wrong, and then we need to be really, really sure because otherwise we may need to roll back. And rolling back is painless. It's one click. You make the other version default, and then it starts rolling, and it's fine. And yeah, that is pretty handy. So our ecosystem of tools looks like this. On the left side in green is basically all the stuff that we need to do. Yes? What about database schema? All our code changes are backwards compatible. Most of the time, more than one version even. So we test for backwards compatibility, which means that you probably basically need to make sure that you make your database schemas ahead of time and make sure that the old code works with that for a little bit before you start doing things. That's not to be undertaken lightly. But yeah, that has in the past bitten us, but that's a few years ago by now, I think. So the blue things are basically ready-made stuff, and all the red stuff is code that we wrote ourselves. So up to the 7, this is actually a very boring part of the presentation, to be honest. Because now that I have explained how we do things, that you have the deploy server, and then we use Puppet and Crutch and DMT to roll the code out. A typical deployment for a data center looks like this. This is what we did in 2011. One day, we go in, we unpack and rack all the servers, and we start a burn-in test. Day 2, we do network installation on site, and we do some testing of the core switches. Mind you, in our plan, we already have complete configuration. So it's not like they need to think about the configuration. We have text files. It's basically a copy and paste job, or they run a script or of some sort to configure the core router and the switches and those kind of things. Day 3, we finalize some cabling and configure firewall or some router. And day 4, we set up the deployment server. Now, I'm saying 4 days, but it's basically all happening at the same time. It's more accurate. But on day 4, we basically have a deployment server, and we have all the hardware profiles inside CMDB, and we're ready to go. That takes about 4 days. And the slowest part of that is actually racking the servers. But that's something you can scale up by just hiring more remote hands to help you rack the servers. So that is how we do it. So in 2011, we deployed 120 servers and switches and load balancers in 1 day, on day 5. Basically, we turned them on, and they started configuring themselves, and then it basically worked. And then we have 2 days left for testing. So that is how you deploy a data center in 7 days. Hmm? Yes, everything is prepared in detail. Yeah. Yes. Yeah. Yes. 2 years, 2.5 years. No, funny. Just kidding. No. Well, actually, you know, if you look at the project plan, the longest wait time is actually turnaround time for hardware. It's not actually doing the configuration. The guys, our network engineer that I work with, we have deployed a total of I think 12 or 13 data centers now. I know him from my time at eBay, and then we do work now at Kobo. We've done it now 3 times for Kobo, and we basically always use the same scheme. So we don't actually make a new plan. We just take the old one and kind of file the serial number off. Now. Basically, the main configuration is fairly similar, so we don't need to work from scratch. And because we are using the same kind of template, it's not exactly the same, of course. But it allows you to make kind of broad assumptions about how stuff works, and that speeds stuff up as well. That is part of the secret sauce. So yeah, have a team that is really well gelled and works well together, and that will help a lot. So actually, yeah. So this is how to deploy a data center in 7 days. But there's also the how to deploy a data center twice in 7 days. Maybe that's more interesting. So if you have a bit of chance, and this is also a true story. So I was flown into California in 2007 to migrate Kijiji into a new data center. So it happened and it was basically the same. The number of servers was a bit bigger. And so day 1, we unpack and rack 800 servers with a lot of people. Day 2, network installation. Day 3, cabling, configure firewall and router. Day 4, set up the deployment infrastructure. Day 5, deploy 800 servers, switches, and load balancers, all from Puppet. And it was actually a bit easier because it was all Unix. So that actually makes things faster. And then day 6, we start testing. And hey, everything worked. The application worked. The only thing that we didn't have yet was the data set. Actually, the live customer data that included credit cards wasn't in there. So we had a test data set that we had in there. I think it was an old scrubbed version from a QA environment that we deployed there. So then this happens. It's around, so the deadline is 24 hours. Somebody had made a promise to the CEO at the time that it was going to be migrated. So it was a little bit of, it was a kind of a high profile project. There was a lot of stress. We had to go live there. And the plan was tomorrow we deploy the live customer data for Kijiji. For those who don't know what Kijiji, do you know what Kijiji is? Kijiji is a classified site. It's fairly well known in Canada, but it's basically like Craigslist. But it's big. It has a lot of customers in there. So 24 hours to go, and we think, we're good. We just need to deploy this thing into the database tomorrow, and then we're basically do some more testing, and then we're fine. But yeah, then this happens. It was about 5 p.m., and my colleague Larry, one of the systems engineers, says, "Hey, Hanno, where is there a local account on this box?" And that's actually a very good question, because we do everything with LDAP, so nobody actually ever makes a local account. And we deploy everything with Puppet, so the boxes are all the same. So why is there a local account? But then the next question they ask is, and why does it have UID 0? That is, for those who may not know what UID 0 is, that is bad. That means that person has root access. It's basically a local root account that is not accounted for. So we start digging in and looking, and there was the case of the disappearing firewall. So originally, we had 6 firewalls in the plan for this infrastructure. But then, for whatever reason, they changed that and said, no, we just do 4 firewalls, 2 pairs of 2 in standby mode, and that's great. But somewhere along the communication, because the data center, the people in the data center and the purchasing were at the eBay site, they had an old version of the plan of some sort, and they actually racked 6 firewalls. with default configuration, which was set to pass-through. So we basically had two firewalls, which were, and because we already had brought our internet link up, we had basically exposed our internal network to anyone who would come in. And somebody had actually gotten in. We didn't find any other proof of malicious activity, actually. When we looked on other servers, it looked fine. We saw 2 or 3 servers that had this strange account. But here's the thing. You cannot actually take the risk. You cannot say, I'm now going to deploy this credit card info for millions of people into an environment that has been compromised, and you don't know how far that the compromise has gone, right? So we had to assume the worst, that there are rootkits installed everywhere. That's why we can't see anything, that it's just pretending to be secure, but it's not. And so we physically disconnected the network from the internet so that nobody could come in anymore. And then we pulled images from the logs and from the compromised servers that we knew of so that we could analyze them later on. And then we changed all the passwords. Actually, we changed all the passwords also on all our other data centers too, just in case, because there were some peer-to-peer links between our data centers that were already live as well. So you never know. But yeah, we have Puppet, so that's easier. So luckily, we all were using Git for our Puppet recipes. And Git is cool because it's cryptographically secure. Meaning that even if somebody tampers with that server, he cannot actually change the commit on disk without Git noticing that something has changed. And all our scripts and Puppet manifests are in Git. And because Git is distributed, we all had copies. We all had copies on our laptops. We had copies on our other servers of these Puppet recipes. So we could verify quite easily that at least that hadn't been compromised. So we re-downloaded the OS images from main, rebuilt the deploy server from the Git repository. It took about 3 hours, and then rebuilt the Puppet master and then checked everything. Took another 3 hours, and then we proceeded to reformat every single of those 800 servers, and also, by the way, the switches and load balancers, which were also managed through Git. It took about 2.5 hours, and we were back online with every single hard disk in that data center reformatted. And we made it. So then we started to do some more testing and deploy the data set. So that's a pretty good example for that. Any questions? Hasn't been asked yet?
Okay.
When the kernel.org got hacked, they didn't trust the SHA-1 in Git repository, so they still went through the whole thing. I heard this from Google guys. So
Yeah,
just
at some point you do have to make you need to weigh the potential risk, right? It's SHA-1, right? So it's.
I agree with you, but I guess I'm just curious what they know that we don't know.
Yeah. Well, I think it was the point that a lot of people had like the Git repositories at home and they were automatically syncing, and they were the same. We checked them and the checksums all were okay. So we felt comfortable enough to move forward with that. Okay. If you are interested in a demo of some of the tools that we've built, please come and see me after because I'll probably set something up. Thank you very much.
Thank you very much, Mr. Liem. Thank you.